Anyway, it's my pleasure to introduce you and your talk about assessing science, which actually takes me also back to the very first paper I wrote on assessing basic research. Relative merits of post-publication review, impact factor, and the number of citations. So Adam, the floor is yours.
Great, thank you very much. Well, it's a great pleasure to be here and to address a very different audience to the ones that I typically address. I've given this talk a few times, but always to scientists, so you're an audience who've thought probably a lot more about these issues than I have. Anyway, so all researchers and indeed scientists on a regular basis, of course, read scientific papers and they form some opinion about them. They form an opinion as to whether they're likely to be right or wrong and whether they're likely to be important or not. And if they're important and right, then we, take note of those papers and keep track of them and so on and so forth. But then, of course, more formally, there is a lot of work that's done on the assessment of scientific papers, either as part of sort of job and promotion committees, but also increasingly governments are getting in on this act. So Austria, the United Kingdom, Australia, all have the assessment of science from universities. So this is, of course, epitomised by what's gone on in the UK. I think the UK has been doing this the longest. So over the last 30 years or so, we've had a series of these research assessment exercises where the government has attempted to assess how good is the science, in fact the research generally, coming out of UK departments. And as part of those processes, a very central element has always been the assessment of research outputs, and for scientists this is typically research papers. The research assessment exercises, of course, mutated into the research excellence framework. I think when originally envisaged, this was going to be rather different to the research assessment exercise, but to me it's pretty much the same thing. So how should we assess research papers, scientific papers? Well, of course, there are a number of different ways in which we might do this. Often viewed as the golden standard is subjective peer review. So get some people to actually read the papers and to form some opinion about how important or how merititious those papers are. But behind the research excellence framework was a push originally towards bibliometrics to maybe look at things like the impact factor of the journal. So probably most of the audience know what impact factors are. But this is the mean number of citations in a particular year to papers published in a journal in the previous 2 years. So if we talk about the impact factor for 2012 for Nature, that is the number of times that papers published in Nature in 2011 and 2010, how often they have been cited in Nature and other journals in 2012. So obviously it's giving you a view, a measure of how often the science published in a particular journal is cited. And that's the mean number of citations per paper. So other bibliometrics, of course, is to think about maybe the number of citations over some period of time, unclear what period of time that would be. And then, of course, there's a lot of interest in these things called altmetrics, other ways in which we might assess the importance of a particular paper or the impact of a particular paper. Things like number of downloads, number of tweets, sort of social media mentions. There's a whole field now which is very focused on these altmetrics. And of course we might think of a combination of the above. So in the research excellence framework, in the scientific fields, it is going to be a mixture of subjective peer review and the number of citations. So some of the panels will be given citation information to make their assessment from. Okay, so in this talk I'm really just going to focus on 3, subjective peer review and 2 bibliometric indicators, the number of citations and also the impact factor of the journal. Now, at the outset, I really want to make a clear distinction between merit and impact. So I see them as 2 different concepts, and possibly the easiest way to understand that is to think of one measure of impact being the number of citations, and as I will argue and show later, the number of citations is a highly stochastic measure of the underlying merit. What do I mean by that? I mean that if you take 2 papers of what we might call the same intrinsic merit, it might even be the same paper, publish them in 2 different places, they will end up with different numbers of citations just through stochastic processes. So I think of impact as you know, a product of merit, but underlying this is some sort of intrinsic merit, indication of the merit of a paper. Now, I'm not going to attempt to define merit too closely. It is really just whatever makes a scientist or a researcher say, this is a great paper, this is a really significant paper, this is a major step forward, this is a paper other people should read. In one of the data sets I will be talking about, merit is a little bit more closely defined as really importance. So you'll see from when I describe the data sets in a Wellcome Trust data set, it's very much about the perceived importance of that paper. In the other data set, it's a little bit more nebulous. Okay. Right, so to try and address these questions about how good are subjective peer review, number of citations, and impact factor in measuring merit, we've analysed two data sets. I did have a third one originally. So the reason I got interested in this field is that I served on one of the research assessment exercise panels in 2008. I rather naughtily kept my data from that, and I initially did some analysis. And when we were getting close to publishing this paper, I contacted Hefke and said, oh, can I publish my results? And I was given a very severe ticking off for ever keeping this data. It was all supposed to have been, burnt in October 2008. So there was a third data set. It no longer exists. Okay, so the first data set I'm going to be talking about is really a beautiful data set, which was compiled by the Wellcome Trust in about 2008, 2009. The original assessments were done in sort of 2006. So what they did was they got 716 papers, which had all been funded in part by grants from the Wellcome Trust. And they gave these papers to a panel of experts, and every paper was assessed by 2 experts. And those 2 experts were asked to assess these papers independently, and they were asked to basically score them on the following scale. 4 was categorized as a landmark paper, so a really major paper of major significance. 3 was major addition to knowledge, 2 was a useful step forward, and 1 was for the record. So here, these assessors have really been asked to score importance of the papers. We compiled Google Scholar citations in 2012, and we've got impact factors as of 2010. The other data set I'm going to talk about is some data we downloaded from the Faculty of 1000 database. So this is a commercial database. Faculty of 1000 has basically assembled a whole load of scientists, and those scientists are asked to find papers in the literature, and if they think they're really, really significant papers, they're asked to then put them up onto the Faculty of 1000 website, write a little bit of spiel about them, and give them a recommendation. So either there's recommended, must read, or exceptional, so getting sort of increasingly interesting. Here, the sort of categorization of merit is a little bit more nebulous as to what they're being asked to do, but importance is going to be a major driver in this data set. We've got a really huge number of papers. So we've got 5,800 papers from biology and medicine. These were all published in 2005, and they were all assessed within 12 months. Some of them, only a subset, were assessed by 2 assessors, so most of them are actually just single assessments. Again, Google Scholar citations, November 2011, impact factors as of 2010. Now, some of you will have appreciated a major drawback with this data set is that these papers are already being sort of selected here. So I'm going to be looking at the division of the scores between these 3 categories. But of course, there is another category, which is that it never gets onto the Faculty 1000 database. So just bear that in mind, and I'll discuss some of the limitations of that as we go through. Okay, so those are the data sets, and the first question we sought to address was how good are these subjective peer reviews of scientific merit? So if scientists essentially agree what merit is, and they're good at assessing merit, then they should typically agree in the score that they give to papers. So when we look at this in both of our data sets, in fact, there's a fairly high level of agreement of around 50%. But actually, you've only got 3 or 4 scores So just by chance alone, it turns out that you would expect people to have agreed 40% of the time. So the level of agreement over random expectations is only a little bit higher. It's really, surprisingly, they don't agree all that much. So another way to look at this, of course, this is just pure agreement, but we might also consider the correlation between the scores. So that takes into account the fact that, okay, so one person might rate it, 4, and another person rates it 3. They're both rating it fairly highly.
Now,
so
in the faculty, in the welcome trust, presumably the raters are independent of one another.
Yes, they are.
That is not true in the...
It's a good point. Yeah, so the faculty of 1000, the second assessor may know the score of the first. So you can view that in two ways. You might think that because the second assessor knows the score of the first, they might agree more often than expected, but at the same time, one of the reasons for assessing, again, doing a second assessment might be to, in a sense, correct the first assessment. So,
who does the first assessment, right?
yeah. So the faculty of 1000 data set is not a particularly nice data set. It's we'd started off with the RAE data, and then we'd done my postdoc at the time suggested faculty of 1000 as a nice, much bigger data set to look at. And then we got the Wellcome Trust data set. And in fact, the Wellcome Trust data set is really the one to look at. But the faculty of 1000 has kind of stayed in there because actually all the trends are very, very similar to what you see in Wellcome Trust. So it's showing that the patterns are very consistent. Okay, so we can look at the correlation. And this is just simple Pearson correlations. And you can see they are very highly significant because we've got huge amounts of data, but they're not really very high. They're pretty modest, showing that really there isn't a particularly strong correlation. If you give the same paper to two assessors, they're not really giving the same scores to these papers. They don't have the same view on how significant this research is. Now, one of the other things you notice in both of these data sets is actually there's a very strong correlation to the impact factor. So the correlation between score and impact factor is actually greater than the correlations between the scores. Now, there's kind of two interpretations of this correlation here between score and impact factor. The first is that, in fact, this reflects variation in merit and the ability of both journals and assessors to pick up on that merit. So there's variation in merit, and let's imagine that journal editors and journals are good at perceiving merit. Then they select high, Nature and Science really do select the best science, and scorers rate that science highly not because it's in Nature and Science, but because it is very good science. So the correlation might be driven by variation in merit and an ability of both scorers and journals to perceive that merit. But of course there is the other possibility, which is that scorers are simply overrating papers in high impact factor journals, irrespective of the merit. Now, and of course it might be a combination of these, and in fact it's very likely to be a mix of these two things. Now, if anybody's actually read the PLOS biology paper, you will know that we went on to give some analysis which supposedly showed that in fact scorers overrate papers in high impact factor journals. Turns out that actually, rather embarrassingly, that analysis was statistically bogus. So a guy called Josh Cherry over in the United States posted a comment on PubMed Commons pointing out that our logic was not correct. So we don't have any evidence that scorers overrate papers in high impact factor journals. But we might suppose that that could be a possibility. So we're just going to bear that in mind. We don't have any evidence that that's necessarily the case. But one of the things we might look at is just to see what happens if we control for impact factor. So what does happen to the correlation between assessor scores? And not surprisingly, it declines. That's pretty much inevitable because you're controlling one variable. Another way to look at it is that, of course, there is going to be some variation in merit, very likely between journals with different impact factors. So controlling for impact factor, you're controlling that variation in merit that exists between journals. But just to give you a feel for really what happens, so the correlations drop off to really very, very small levels if you can control for the impact factor. Okay, so one of the things we might want to know is really what do these correlations mean? in terms of, some model about the process of assessing science. So let's just start off with a very simple additive model. So we're imagining that the score of a paper is equal to the merit of that paper plus some error associated with making that score. So if we take that very simple additive model, it turns out that the correlation between scores is just 1 over 1 plus the ratio of the variance associated with the error to the variance associated with the merit. So we can convert that correlation into something that maybe is a little bit more intuitive in its interpretation. So when we do that, if we just look at the straight correlation, so the straight correlation between scores, this gives us an estimate of the relative variance associated with the error of making that score relative to the variance in merit. And it comes out that around the variance in error is about twofold higher than the variance in merit. So in other words, if you're making an assessment of a paper, most of your assessment is actually error rather than being directed by the underlying merit. If you take the partial correlations, and this is a very extreme view, so it's effectively assuming that all the correlation between score and impact factor, all of that is just due to bias. Then we look within journals, essentially, what is the correlation between scores, and we get those very low partial correlations. And now the variance, the error variance associated with your assessment is around 5 times higher than the variance in merit. So the take-home message here is that your assessment, whether you take out impact factor or not, your assessment is dominated by error. So first set of conclusions is that subjective assessments are clearly not very good, and if we quantify that, the error variance is at least twofold higher than the variance in merit. So, okay. So we might ask a second question, which is, are we any better at actually predicting the impact, the future impact of a publication? And here I'm taking a very basic view of impact, which is simply the number of citations. So we might look at impact in all sorts of different ways, and the reason people actually cite papers are for a variety of reasons, from actual knowledge of the field to laziness about what they're citing, etc. So anyway, we might look at this, and again, what we find actually quite surprisingly is that the correlation between the score and citations is actually very similar to the correlation between the scores. There's no reason that these should be so similar. They just happen to be this similar. And again, I would reiterate that the correlation to the impact factor is considerably greater than either of these sets of correlations. If we control for impact factor, just to give us an idea of what would go on inside, within journals, then the correlation between, of course, if you're controlling for impact factor, clearly the number of citations and the impact factor are correlated themselves. It's just giving you a view. So if you look within a journal, then you're seeing very, very low correlations between assessor scores and the number of citations. So you can do that using these partial correlations, but actually you can just look at the journals with the biggest number of papers, and you get very much the same sort of picture. So look within Science, look within Nature, you get exactly the same picture. Okay. So we don't seem to be particularly good at predicting the likely impact in terms of the number of number of citations that a paper will get. So let's now move on to thinking about some of these bibliometric measures, and the first one I want to address is the number of citations. So as I said earlier, it's very likely that it's a stochastic process, the accumulation of citations. So if you take 2 papers, they may even be the same paper, and publish them in 2 different journals of similar rank, they will get different numbers of citations. And that might just simply be because one of them gets noticed by someone who's big in the field and, say, gets cited in a Nature paper, then everybody knows about that particular paper, whereas the other one drops off into obscurity. So we can attempt to estimate the variance associated with the accumulation of citations by basically combining information from the correlation between the score and the number of citations. So if you look about the correlation between score and the number of citations, it's expected to have expected to have this equation here, where these R terms, so the first R term is the ratio of the error variance associated with making a score versus the error variance, relative to the variance in merit. So this is what I've shown you already in terms of the error variance associated with the scoring relative to the variance in merit. And this term here is actually the variance in the accumulation of citations relative to the variance in merit. So basically, by combining information that you get from the correlation between scores with the correlation between score and citations, you can actually infer what sort of variance is associated with the accumulation of citations. So if you do that, if we just use our sort of straight correlation, so not controlling for impact factor, then we find that the variance in the accumulation of citations is about 1.5 times greater than the variance in merit. So again, what we're finding is that the number of citations a paper gets is largely dominated by error rather than merit. If we take the partial correlations, which is a very extreme sort of perspective, then we're seeing very much substantially higher levels of stochastic variation. But again, the take-home message is that a lot of the variation you see in the number of citations is actually just stochastic noise. It's not anything to do with merit. In fact, the situation is probably a lot worse than I'm indicating here, because one of the things we know is that the journal in which you publish almost definitely affects the number of citations, and there's going to be error associated with whether you get into a journal or not. So getting into, we don't all, but, sometimes you submit your paper to Nature. I submitted the paper that this work was eventually published in. I submitted it to both Nature and Science, and they both rejected it without review. There I'm implying that it should have been in Nature or Science, which is not necessarily the case. But there is definitely error associated with whether a paper gets published in a journal, because basically that decision comes down to the editorial staff, and they're human. They're just like everybody else. They're going to make mistakes. So there's an additional source of error, which is what journal you get published in, and where you get published does influence the number of citations a paper will get. This was beautifully demonstrated in a paper which many of you are probably familiar with, a paper by Lariviere and Gringas. So what they managed to do is find 4,500 cases in which the same paper had been published in 2 different journals. So biology, I'm glad to say, is not an offender here. There are very few papers in biology where the same paper is published in 2 different places. Biomedical science is a big offender. Physics is a big offender. So they could ask, of these 4,500 cases in which the same paper had been published twice, if we look at the number of citations the paper gets when it's published in a high impact factor journal versus a low impact factor journal, do we see the one in the high impact factor journal actually getting more citations? And indeed you do. In fact, the ratio of the number of citations in the high to the low impact factor journals is nearly 2. So the one published in the high impact factor journal is getting about twice as many citations as the one in the low impact factor journal. Now, rather strikingly, if you look at the ratio of the impact factors themselves, it's about 2.4. So I draw your attention to the similarity in these 2 numbers. So the impact factor, of course, is determined by 2 things. It's determined by the quality of the papers being published, and it also is determined by the kind of reputation of that journal and how often people read it and tend to cite the work. So, you might get 2 papers, same paper, published in 2 different journals, and we're showing that there is a journal effect. So, well, we aren't, they are. They show there was a journal effect. The fact that these numbers are so similar is actually suggesting that, in fact, the differences in the impact factor are largely driven by this sort of positive feedback loop. It's got nothing to do with actual intrinsic merit. So the high impact factor journals in a study are not actually publishing really much higher quality science. they're just getting a higher impact factor because they're attracting more citations. So you've got this kind of positive feedback, I think, that a journal gets a reasonable impact factor, therefore people read it more, therefore they cite the papers in that journal more, get a sort of positive feedback. Now, I would draw you, also mention, however, that as you might expect, given these papers, same paper published in 2 different places, I think you can only probably get away with this if you're publishing in fairly low impact factor journals. And in fact, the mean impact factor for these journals is really very low. It's less than 1. So certainly within biology, that's really at the very tail end of journals. So I do believe, and I'm going to go on to argue this in a bit more detail a bit later, that actually impact factor probably does reflect merit to some extent. But it's clear that it's not a quantitative but a qualitative measure of merit. Okay, I'll elaborate on that or reiterate that a bit later. Okay, so the second load of conclusions is that the accumulative of citations appears to be a highly stochastic process. If anybody's really watched the accumulation of citations on their papers, you probably understand that. I mean, it really is. You know, you can see the fate of your own papers as they live and die. And the error variance associated with the accumulation of citations is at least 1.5 times the variance in merit. So there's lots of stochasticity going on here. And finally, it's not our work, but the number of citations does appear to be affected by the journal, at least in the low impact factor journals. Okay, so that's the number of citations. What about the impact factor? So I don't know about in the more sort of sociological field one's perception or the field's perception of the impact factor, but certainly in science, people hate the impact factor, and you get numerous editorials decrying the use of it, and I have some sympathy with that. And this has really found its voice in something called DORA recently. So this is a San Francisco Declaration of Research Assessment. It was a declaration published in a number of leading journals earlier this year. And a whole load of leading scientists signed up to this, a whole load of leading journals signed up to it. And really, they were saying, basically, they were encouraging the field to abandon journal-level metrics, things like the impact factor, and actually encouraging us all to really employ either subjective peer review or article-level metrics to assess the quality of a particular paper. So, you know, subjective peer review is often held up as the sort of gold standard. Everybody says, which is, you know, perfectly logical, you know, go and read the science and really form a properly informed opinion. Of course, what I've shown is actually neither of these are particularly good. So, okay, we can all go and read science or the research and form our opinion, but you should be aware that your opinion will differ to other people's opinion. The other thing is that article-level metrics, again, and certainly in terms of the number of citations, and we haven't studied other article-level metrics like downloads, tweets, etc. Again, we've shown there's a lot of stochasticity associated with this. I have a lot of sympathy for DORA and what they're trying to do, but at the same time, I can't help noting that there's a logical inconsistency in what they're saying. Because basically, the field decides where a paper should be published. You know, it's not completely random that a paper gets into Nature. People submit their papers to Nature, and well-informed people make that decision as to whether this science is good enough. So it's not a sort of random process. There's nothing sort of dark and Machiavellian. Well, there might be some Machiavellian stuff going on, but, you know, it's not. So there's lots of editorials which have been written about DORA since then, and every one of them says, you know, it's terrible that we use the impact factor. We've got to just read the science. And the only person I've come across who's got anywhere close to this, acknowledging this logical inconsistency is Mark Patterson, who wrote an editorial in the journal Genetics. And basically, he appreciated that it was scientists who were deciding where a paper should be published, or scientists and editors, and you know, and then he really basically went on to say that, oh, okay, well, I do acknowledge that, in fact, you know, the field is making a decision, but actually, really the people making this decision, the editors, are someone with little experience as a practicing scientist and often with no experience as an independent investigator. Doesn't give any evidence of, to support that statement. And it's clear that actually, I would say actually most editors in the science journals are reasonably well-informed and reasonably competent people. They're not going to be right all the time, by any means. So I find this all a little bit frustrating, this DORA, that in fact this is not really acknowledged, that in fact we as a field do decide where papers get published. One of the things that, of course, people really hate about the impact factor is the fact that the impact factor does not represent the number of citations that most papers actually get. So this was a point made by Per Seglen way back in 1997 in BMJ, where he noted that there was a very strong skew in the number of citations across papers. So this is for 3 biological sort of chemistry, biochemistry journals. Here we've got the number of citations, and this is the number of articles. So you can see in these 3 journals, all of which have an impact factor of around 5. So the mean number of citations is around here. There are a whole lot of papers which almost never get cited. They either get cited once or not at all. And there are a few papers which get cited loads and loads of times. And this has been used as an argument that journal level metrics, the impact factor, is not a good measure of the merit of the papers because, in fact, it is just the mean number of citations that all papers get, and some papers are doing much better than other papers within a journal. I would point out that, of course, we've shown that the accumulation of citations is highly stochastic. So you could have a situation in which the impact factor was a perfect measure of merit, and you would still get tons of noise in terms of the number of citations that each paper independently gets. So this skew in this distribution could actually also be due to that stochastic noise, and the impact factor could, it's not going to be, but it could be a perfect measure of merit. There are, of course, some other disadvantages to the impact factor. It is clearly going to be error-prone because the people deciding where a paper should be published, they are human, they will make mistakes. And we've seen that, as far as we can make out, scientists appear to be bad at judging the intrinsic merit of a paper, the likely importance of that paper. One of the things I think is also really a problem with the impact factor is actually, in a sense, just our reaction to it. So I think, and we don't have any evidence of this, but I strongly suspect, and this is supported by that Riviere and Gringa's analysis, that actually papers published in high impact factor journals, we tend to think that they're better than they are. A lot of people have complained, of course, about how the impact factor is calculated. It's very obscure. ISI don't make their calculations public. It's not clear what sort of categories of papers are included, and we have the problem of review articles. I have sympathy with both of these, but I don't think these are actually major problems. Although I have come across a most blatant attempt to influence the impact factor in a journal. So one of the journals I publish in is something called Molecular Biology and Evolution. We recently had a new editor take over, and as soon as he took over, he issued a call for papers. And the call for papers he issued, of one of them, was for updates to pre-existing software packages. So what he's doing here, so he's not interested in new software packages, he's interested in updates. And he's interested in updates because he can just look to see, has that software package been cited in the past a lot? And if it is, we'll have an update note, because then they get all the citations for it. I think that's just disgusting behaviour. It really is. Okay. So, of course, there are problems with using impact factors. We have to take into account subject differences. Some subjects tend to have journals which have much higher impact factors, like molecular biology has high impact factors, ecology has low impact factors. We have to sort of control for that. If we don't control for that, everybody will end up doing molecular biology and we won't have any ecologists. The other thing I would emphasize is, based on that Riviere and Gringa study, the impact factor is not going to be a quantitative measure of merit. it's going to be a qualitative measure of merit. So, you know, if you published in a journal with an impact factor of 30 relative to one with an impact factor of 5, the papers in Nature are not, with an impact factor of 30, are not 6 times better than the one with the impact factor of 5, because Nature is getting a lot of its citations just through its reputation. It'd be lovely to try and actually quantify that. Okay, so one of the advantages of using the impact factor, well, it is to some extent a form of pre-publication peer review. So in some ways I can't see how you can really do better with post-publication peer review unless you're going to employ a lot more people to do it. So, you know, the impact factor is to some extent a form of pre-publication peer review. People are deciding the merit of a piece of science and deciding where it should be published. Of course, there are some individuals who have much more power in this decision than others. So it comes down, to, of course, to really the authors, how they rate their own science, the editor. So the editor really has, you know, where you've got sort of single professional editor or a series of professional editors, typically they're wielding huge power. So there was a talk over in biology just the other day by one of the senior editors at EMBO Journal, and he admitted that basically he was making most of the decisions by himself in his particular field of whether they reviewed a paper. So it didn't go to a sort of discussion, you know, around the board. Basically, he was making a decision, and he was rejecting about 80% of the papers without review. So he wields a lot of power, but, you know, he's a well-informed person. He has probably a very good perspective on the overall field. And then, of course, the reviewers ultimately come into it. If it is sent out for review, then the reviewers have some say as to whether that paper is important enough, significant enough to be published in that journal. Now, when we were going through the refereeing process of our paper on the assessment of science, the editor who was handling it for PLOS Biology remarked to me that actually she didn't find it surprising that we got such low correlations between assessor scores, because her experience of actually acting as an editor is that, in fact, individuals reviewing papers rarely agree about the significance of the work. So, okay, so if we've got several individuals, basically, let's imagine we have n independent individuals, then actually they reduce the error variance associated with the overall assessment by n-fold. So if we say, for instance, that the error associated with making an assessment is, say, 2 times greater than the variance in merit, if you employ 2 people to do the assessment, actually the error variance should be equal to the variance in merit. And if you use 4, it will be half the variance in merit. So by employing multiple people, you can improve that assessment. That's hopefully pretty obvious. There are some other advantages to using impact factor in things like the ref. The first is that it's actually relatively cheap to implement. It's instantaneous. You don't have to wait for things like citations to accumulate. You don't have to wait for someone to actually referee or review the paper and give you their assessment. And finally, it's actually transparent. So one of the things with the Research Excellence Framework, Research Assessment Exercise, is that, of course, all individuals, certainly the sciences, who are submitted, have to submit 4 papers. So you have to make a decision as to which 4 papers you're going to submit. And it's actually far from obvious what you should do. So I really had a decision to make between submitting a paper in a reasonably ranking journal, which had been cited a modest amount of times, and a paper published in a low-ranking journal, which actually had been cited far more times. So which of those should I submit? You know, it's completely unobvious what you should do. So you're trying to second guess how the panel is going to behave. Okay.
To leave time for discussion, can you finish in the next 5 minutes?
I can indeed, actually. I think I'm just about to wrap it up. Okay, so third set of conclusions. So the impact factor is likely to be a poor measure of merit. I don't see it as being necessarily, and there's no real evidence that it's any worse than anything else at assessing merit. And I've just given some other sort of on the previous slide. So just want to address briefly the Research Excellence Framework, which we're just about to go into. a major component, 65%, certainly in the sciences I'm involved in, are the assessment of outputs. This is going to be done by subjective peer review and the number of citations, both of which we've shown are highly error-prone measures of merit. So that's telling you that these assessments that are going to be done during the Research Excellence Framework are going to be pretty noisy. The other thing I haven't addressed, which is I've shown that these peer review, subjective peer review are error-prone, but actually they're also likely to be biased in the sense that some assessors are likely to score more harshly than other assessors. And that will be particularly significant for some departments which are small, where most of the people do a particular type of science. So if you've got one department that just does ecology, then they're all going to be assessed by 2 people probably. And if those assess harshly, then they'll end up, with a poor score. If you want to know a little bit more about this, ask me after the talk. Since we're recording this, I won't say any more. Yes, I could pause. Costs. So the Research Excellence Framework is, and the Research Assessment Exercise, these are very expensive processes to do. So it cost £60 million at the last Research Assessment Exercise, 12 million in direct costs, but 48 million was consumed in just universities preparing their submission. So you have to ask yourself, if you're going to get really, really noisy data out of this sort of process, is it really worth spending all of this money? Now, there's 2 reasons for doing something like one of these assessment exercises. One is a genuine attempt to allocate funds to the departments which are doing really well. And I would argue that actually probably these assessments are so noisy that I'm not sure you're doing this very well. The other reason for doing it is, of course, it's just a stick to beat universities with to make them perform better. And I'm sure that actually has had an effect. That, in fact, by threatening to cut off funds, it does make everybody try a bit harder. Okay, so overall conclusions. I'm really concluding that all of these forms of assessing science are pretty poor. They're all very error-prone. They all have their own disadvantages and advantages. But the overall message is that actually it's very difficult to assess the merit of scientific publications. I'm not really giving any great solutions to this problem. I'm just pointing out that there's a big problem. And then finally, I'd just like to thank Nina Stiletsky. She was a postdoc with me for a while, but in fact we didn't do this project while she was a postdoc. She flew the nest and went somewhere else, and it was done sort of on and off over a lot of years, actually. Okay, thank you very much.